It's The Tonight Show with Galeno, featuring Reggie Brown and the Galeno Show Band. Tonight, Galeno welcomes Mr. H, William Shatner. And now, Galeno.
Welcome to the Galeno Show. Thank you all for coming. It's nice of you to be here. Real nice. Thank you. Thank you. So, tonight we have a great show planned. Some great guests. We're going to start off with an accomplished physics professor, an entertaining speaker. So, put your hands together for Mr. H.
Hey everyone, hey, it's great to be here. Thank you so much. Mwah, mwah.
So, it's nice to meet you. Really nice.
Oh, no problem, no problem.
So, before we start, I have to ask you, what is the deal with Mr. H?
Well, I am a professor, so I like to keep it short and sweet for my students.
Well, you see, this isn't school, though, so maybe you could let the audience in on your full name. You know, make it a little more personal.
Well, I don't think the audience knows your full name either, only maybe a first name.
Touché. Well, anyway, it is Wave Week on BSTV, and I hear you're teaching your students about waves right now, so why don't you tell us a little bit about that?
Alright, fantastic. So, alright gang, does anyone know anything about waves? Check your neighbor.
Waves are in the ocean!
Well, he is right, you know. Waves in the water are one type of wave. But there are also many other types of waves, like sound waves. There's many sound waves around us right now. Now, both of these waves can move through almost any medium, a medium being just the stuff a wave moves through, like air or water. However, despite these similarities, there are differences between both types of waves as well. You see, gang, it's all about how these waves move. Waves in the water, they're moving up and down. Imagine you're on a boat. Wave comes underneath, you're going to be bobbing up and down. Now, we could say that the waves are moving perpendicular to the medium. The wave is going this way, and the water is going up and down, perpendicular. Now, we call these perpendicular waves transverse waves. We've got a bit of nomenclature to go along with these waves. When we get to the top of the wave, highest point, we call that the crest. At the lowest point, we call it the trough. On the other hand, sound waves, they move a little bit differently. They move back and forth. So when I'm talking to you, the sound wave is going to move back and forth through the air until it gets to your ears. Now we can think of this as the medium moving parallel to the direction of the wave. So for example, the wave is moving in this direction, the medium moves along in the same direction. We call these type of wave longitudinal waves. And of course, we got a little bit of nomenclature to go along with these waves as well. As you can imagine, as the wave is moving through the air, there's going to be some parts of the air that are a bit more compressed, some are going to be spread out. Now we call these compressed parts, yeah, you guessed it, compressions. But these spread out parts, we call these rarefactions. Now you want to hear something really neat, gang? We can take the displacement of either one of these waves. Displacement is just the distance the medium has moved from its original starting position. And we can put it on a graph. Now here's the really neat part. If we look at either one of the graphs for either one of the waves, they're both going to look the same. Same. Let's take a look at what the graph would look like.
Let me walk you through this graph. First, the amplitude. The amplitude is the maximum displacement of the medium from the original position. In addition, there's the wavelength. The wavelength is the distance between two crests, or two troughs.
So, Mr. H, this is all very interesting, but I have to ask you, what happens when two waves meet?
Well, that's a good question, because waves are all over the place. I'm talking to you, you're talking to me, so they're bound to bump into each other. Luckily for us, waves combine pretty easily. They just add together. Let's take a look at a few examples.
Now what you're seeing here are some waves adding together, or in fancy terms, the superposition of two waves. We can group the way waves interfere into two categories, constructive interference and destructive interference. Constructive interference is when the resultant wave is larger. Destructive interference is when the resultant wave is smaller. Supposing we have two waves that are the same but moving in opposite directions. If we add them in a few different places, we see a neat pattern. You may notice that the resultant wave crosses the center line at the same place, no matter where the waves are added. For this reason, we give these waves a special name, standing waves. And now I'll talk about some standing wave terminology. Here we have a little visual of a standing wave in its two extreme positions. Notice that it always crosses the center line in the same place. The places on the center line that never move are called nodes. The parts of the wave with the largest amplitudes are called the antinodes.
More with Mr. H when we come back.
Hi, I'm Adam from Wave Watchers. Are you feeling your amplitude's a little larger than you want it to be? Try Wave Watchers. Here's some real-life testimonials to convince you.
My amplitude used to be off the charts, but thanks to Wave Watchers, I learned about destructive interference, and now my amplitude is plummeted.
Hi, I'm someone famous, and like many of you, I used to have a large amplitude. Wave Watchers turned my life around.
My amplitude used to be dangerously high, but Wave Watchers helped me dampen it. Now it's under control.
If Wave Watchers worked for all of these tsunamis, it can work for you.
Your standing wave not standing as tall as it used to? Harmony not quite right because you can't find the superposition? Not anymore.
Coming up next, Sexy Science with Rex Rodriguez. First, I'll show you the ins and outs of good harmonies. Afterwards, he'll give wave interference a dressing down. Don't miss it. Also, don't miss the new episode of Daily BS on Wednesday at 9 p.m. featuring a special on modern musical instruments from Japan. Now, Wave Week continues with Galeno on BS TV. Basic science for basic people. And we're back with Mr. H, who's going to tell us more about waves. In particular, I think we're going to talk about what happens when waves change media.
That's quite right, because like it or not, we have to accept that waves will eventually reach the end of their medium. What happens next is quite interesting. So, when a wave reaches the end of its medium, some continues into the next medium, and some of it reflects back. Let's focus on the part that reflects back for a minute. Now, as you can imagine, any medium has a length. Maybe it's the length of this room, maybe it's the length of a musical instrument. And if the wavelength of the wave fits evenly into the length of the medium, then it'll reflect back and forth and interfere constructively with itself. This gets us a nice, big, meaty standing wave like we saw previously. This is called resonance. All objects, or media, have a number of wavelengths that will resonate in them. The longest wavelength that resonates is called the first harmonic. So let's take a look at a graphic to show you what's going on.
As you can see, the first wave in the picture is the first harmonic. It is the full length of the medium. The second harmonic is depicted below. It is half the length of the medium. The third harmonic is a third of the length, and so on. All of the harmonics fit evenly into the length of the medium.
Now here's an example for you. Galeno, do you want to whip out that French horn you have
Oh,
there?
sure, I just have it kicking around.
Now that was the first harmonic. To get to the second harmonic, we just have to add more energy, in this case by blowing harder. And the third harmonic. And the fourth harmonic. And so on and so forth. To get to higher harmonics, we just have to add more energy. Now, the series of sounds we produce with these harmonics is called the overtone series.
Well, that's very interesting. Now I think we have a bit of an understanding of how musical instruments work.
Well, gang, now that you have a basic understanding of sound, I think my work's done here.
Well, thank you very, very much for joining us and sharing your wealth of knowledge. It was great talking to you.
Oh, thank you, thank you. Mwah, mwah.
Coming up after this break, we'll be talking to a man who knows his science fiction. William Shatner. Be right back.